Hello, Algebra 2. How you doing? Let's jump right into it. We are looking at lesson 7.5. You're watching this right after, sometime after recently completed the ACT, so I hope that went well for you. I wish you the best with your scores. I hope that went all right. We are moving on from the ACT, however, and continuing on with our Unit 7. And we're still looking at these rational expressions, which recall rational expressions are, where we have x in both the numerator and the denominator, to put it plainly, right? So now we're looking at equations, right? There's an equal sign, and we're actually going to solve for x. If you recall, in our previous notes, we've been just simply adding and subtracting, and in 7.3 multiplying and dividing, but we weren't really solving for an x value. Well, now we are. This is an equation, and we can solve. And the focus of today's lesson is to solve by cross multiplying. There are many methods. Well, I shouldn't say many. That makes it sound like there's a super long list. But there are several methods that one can use to solve these types of equations. And the method that we're going to look at today is cross multiplication. Cross multiplication is something that you're pretty familiar with from Algebra 1 and probably like a pre-algebra course or like a 8th grade math maybe. And that's just the idea of taking the numerator times the denominator of the other and the numerator times the denominator of the other. And when you cross multiply, we're doing 2 times x plus 1 equals 3 times x minus 3. And what's important, and what I'm really stressing here with the parentheses, is that when we perform this multiplication, we have to distribute, right? It's not just 2 times the x, it's 2 times x plus 1. So 2 times x and 2 times 1 equals 3 times x and 3 times negative 3, right? It's important that we distribute this. And then once we cross multiply, we've created an equation that's relatively simple, right? Get your like terms together. So I'm going to subtract 2x from each side in order to cancel that out. So I have 2 equals 3 minus 2 is 1. So we have a single x minus 9. And then add 9 to each side. X equals 11. So our final solution is x equals 11. But remember, with rational expressions, there are some values that are excluded. Why? Because we might just happen to be dividing by 0. Because we have fractions, the nature of fractions is that theoretically our denominator could be 0, and if that were the case, we have a fake solution, an extraneous solution. So anyways, what are our undefined values? Looking at the first fraction, x cannot be 3 because 3 minus 3 is 0. Can't divide by 0. And x cannot be negative 1. Negative 1 plus 1 is 0. We can't divide by 0. So our x equals 11 solution is A-okay. Now, if we solve this all the way out and our answer happened to be 3, well, then that means there is no solution for this equation. But x equals 11 is our final solution. Moving on to the next problem, we are going to cross multiply still. But you might look at that and go, well, 2 doesn't have a denominator. Well, remember, everything can be divided by 1. So this 2, we're going to imagine as 2 over 1. 2 over 1 is 2, right? I'm just reformatting the question to my liking here. And what are we going to do? We're going to distribute when we cross multiply. We're going to distribute when we cross multiply. I'd like to make this the first question. What is the expression going to be when we cross multiply? When we distribute. What are we about to get? What is our answer when we take 2 times x plus 3? Here's some multiple choice options on the screen for you. So what is the result when we distribute? 2 times x is 2x. 2 times 3 is 6. equals 1 times x is x, 1 times 1 is 1. And now from here, same thing as we did before, get our like terms together. So I'm going to subtract this x plus 6 equals 1, and I'm going to subtract this 5, or that's not a 5, silly me, that is a 6. Subtract this 6, 1 minus 6 is negative 5. What are our excluded values? X can't be negative 3. So turns out this answer is A-OK. We're just going to do several examples in a row, and then we're going to be done. This is going to be a pretty short video. Continuing on, let us cross multiply. And when we cross multiply, we are most likely going to be distributing. Here we are, 5x squared, that's new. X times 6 is 6x. And then 7 times 3x, that's just 21x. There is no distributing, right? Because that's just a single term. Why is there no distributing? Because of what I just said. That's a single term, and this is 2 terms. That's when you have to distribute. Here, it's just a simple multiplication. So what are we looking at here? What are we looking at here? This is a quadratic equation. This is a quadratic equation, right? Because we have an x squared. And how do you solve quadratic equations? You set it equal to 0. So I'll continue in green. When we set it equal to 0, that means we need to subtract this 21x over to cancel that out and set it equal to 0. So 5x squared, 6 minus 21. What is that? Negative 15x, right? Yes, negative 15x. And then from here, we factor. There's only 2 terms. We're simply looking for a GCF. What do both of these terms share? A 5 and an x. And I'm left with x minus 3. So my 2 solutions are zero when I set that factor equal to 0, and 3. 0 and 3. What are our extraneous values? Our extraneous values are 0. 3 times 0 is 0. And then simply plugging in 0. So x cannot equal 0. That's the only excluded. I think I said extraneous. Extraneous, excluded, they mean the same thing in a way, right? So this right here is an extraneous solution. It is excluded. It is not true. There's only one solution to this, and that is 3. So there we finally saw the importance of stating the excluded values, because if you don't recognize what's excluded, you might accidentally include an incorrect answer. All right, still plugging along. Let us cross multiply and solve. 2x times 5x and 5 times x squared minus 5x. So here's another question for you offhand. What is this going to multiply to be when we do 2x times 5x? Let's just make sure we're on the same page. What's that going to be? A few answer choices pop up. That's right, it's going to be 10x squared. 2 times 5 is 10, x times x is x squared. And when you distribute the 5, you get 5x squared, and distribute the 5, you get minus 25x. Once again, we have a quadratic equation because of the x squareds. I set it equal to 0. I also need to move that in order to set it equal to 0. I probably could have done that in one step, but I didn't, and that's okay. And now, this is the same situation as the previous one. Let me take a step back. Why did I set it equal to 0? Because I saw the squareds and I knew it was a quadratic equation. The only way to solve a quadratic equation is by setting it equal to 0 and factoring. So now I take a look and I say, what's the GCF? They both have a 5, they both have an x, and I'm left with x plus 5 in parentheses. So this gives me a solution of 0, and this gives me a solution of negative 5. But wait, let's go back up and check our excluded values. Once again, we can't plug in 0. X cannot be equal to 0, so that is once again an extraneous solution. Let's keep it going. We cross multiply. Check this out though. We have a parenthesis times a parenthesis, right? When we cross multiply, we're doing these two things times each other. Please remember how to multiply these things together. A common mistake that I often see is that students want to say the answer is 12x squared plus 13. They do 3x times 4x and -1 times -13. That's not the whole story. You are missing key details. And a little organization tool that I like to use is the box. I call it the box method. And if this helps you, please do it. We've done this before in class, where I simply make my box like so, and I write 4x minus 13 across the top and 3x minus 1 down the side. It doesn't matter which way you do it. I could have those switched. The point is this makes you do all the multiplication. 3x times not just the 4x. I mean, we are going to do that, but 3x times -13 as well, which comes out to be -39x. And then -1 times 4x, which is -4x, and -1 times -13, which is +13. So when you combine them all together, the whole story is 12x squared. -39 and -4 make -43x plus 13 equals, again, another box method in order to multiply that one together. We get 6x and -2, 2x and 5. So that's 12x squared minus 4x, 30x, and -10. 12x squared, 30 minus 4 is 26x, and -10. Interestingly enough, we ended up with 12x squared on each side. So when I try to combine my like terms, right, when I try to combine the x squareds with the x squareds, they just end up canceling each other out, which is honestly nice, right? Because if the x squareds disappear, that means I'm not going to have to factor like we were in the previous two. We do need to continue combining our like terms, so I'll add the 26x. What is I don't want to mess that one up. What is -43 plus 26? I believe the answer is 17, but I won't. -17. X plus 13 equals -10. I will subtract the 13, and I get -23, and then we end up with 23/17. Is that supposed to come out to such a nasty fraction? Let me pause my recording real quick and just double check that I didn't do something stupid. I caught my mistake when no, I didn't. Oh no, never mind. I didn't catch a mistake. I thought I did. That's right. -4x, +13 because of the two negatives. Let me pause again. I'm sorry. I just want to make sure I don't screw you over. I found a mistake. But I guess that's why I checked my work. I just didn't want to waste your time with me checking my own work. This was a +30x, so 30x minus 4x gives me a +26x. So I was supposed to be adding the 43x, because I don't want to have -x, so I'm going to add 43x, which comes out to be 69x, and then I'm going to add the 10, which comes out to a 23. And when you do that, that's actually a perfect 1/3, a much nicer answer. 23 times 3 is 69. So we end up with 1/3. Is that an excluded value? We look back up at here. The excluded values might be a little less obvious. 6x minus 2 equals 0. What is excluded here is 1/3. 1/3 is excluded. Look at that, right? If I plug in 1/3, what's 1/3 of 6? 2. And 2 minus 2 is 0. So actually, that is excluded, and we have no solution. By the way, the other excluded value here is 13/4. Right? You just simply add the 13, divide the 4, and you get 13/4. But that one doesn't matter as much. Sorry for my typo there with the positive, but luckily I paused it and fixed it for you. All right, last question on the notes, and I'll include one last question for the sake of participation here. Let's see where this takes us. We cross multiply, and we get x squared equals 2x squared minus 16. I hope you're okay with me jumping a little bit straight to the point, right? I did x times x, boom, and I distributed it as I went along, right? If that's something that you're capable of doing, I encourage you to do so to save a little bit of space. So there's that. This is a quadratic, so we set it equal to 0. We subtract the x squared, and we end up with 0 equals x squared minus 16. We have to factor this. This does not factor with a GCF, however, like some of the other ones. We have to, create our two parentheses like we're used to doing, right? So, what is that? What's the right answer here? Here's a couple of answers popping up on screen. How do we factor x squared minus 16? How do we factor it? It is a difference of squares. So what's the square root of 16? 4. So plus or minus 4. X plus 4, x minus 4. Another way to think of this, right? What's the pattern that we look for? What multiplies to the last number and adds to the middle number? Well, the middle number in this case is simply a 0. It's non-existent. So what multiplies to negative 16 and adds to nothing? 4 times negative 4 is negative 16, and 4 minus 4 is 0. So lastly, whoops, I don't need to write that anymore. What are our two solutions? Negative 4 and 4, right? It's just the opposite. What is excluded? What is excluded? This would give you an excluded value of the square root of 8, which is kind of weird. And this gives you an excluded value of 0. So we have two solutions. Once again, we're A-okay here. Negative 4 and 4. And that is our lesson. I appreciate you watching. I appreciate your participation. I hope you don't feel too intimidated by this, considering every problem is done the exact same way. Kind of a nice change of pace, right? Be prepared for the factoring, though, of course, right? Be prepared for the factoring. All right, I'll leave you to it. Get started on that 7.5 classwork, and have a good rest of your day, whatever day this is that you're watching it. Adios.